This problem is based on Norrish type cleavage. When the cyclohexanone with cyclopropyl moiety on the alpha carbon is subjected to photolysis, what is the product? As soon as you see H mu on the equation, you have to think of electrocyclic ring closing and ring opening, remote functionalization, Norrish type cleavage, last one Paterno-Bucchi, and dipymethane rearrangement. For electrocyclic ring closing and ring opening, we need conjugated polyene, maybe diene, triene or tetraene. In the given substrate, we don't have any double bond. Because of that, it is not electrocyclic ring opening or ring closing. When you go for remote functionalization, there should be ONO or OH, which is treated with NOCl. In the case of Barton reaction, this bond will undergo homolytic cleavage to give O radical. Because of that, we get remote functionalization. Or there should be N-chloroamine. These two are the requirements for remote functionalization. This is for Hofmann-Loeffler-Freytag reaction. For Paterno-Bucchi, we need ketone as well as alkene. There should be two substrates, but here we have only one substrate. Because of that, this is not possible. For dipymethane, we need methane with two vinyl groups. We don't have that here. So this also is not possible. We are left with only Norrish type cleavage. We are left with only Norrish type cleavage. Here we have Norrish type 2 as well as Norrish type 1. First let us go for Norrish type 2. In Norrish type 2, the gamma hydrogen will undergo homolytic cleavage, alpha, beta and gamma. As a result, what we get is a diradical. Further, these two may combine to give you a tricyclic compound, but that has not been given in the option. Or this bond may undergo cleavage to give this enol and cyclopropene. This is another possibility. In the options, this has not been given. Similarly, the tricyclic compound also has not been given. So I can eliminate Norrish type 2 cleavage. Now let us go for Norrish type 1 cleavage. In Norrish type 1 cleavage, the bond between carbonyl carbon and alpha carbon will undergo homolytic cleavage. As a result, what we get is a biradical like this. Further, this bond may be opened up to give a double bond here. When I generate a double bond, the double bond may be cis or trans. Now, these two radicals may combine to give a 9-membered ring. There are 9 carbons. In that, there will be double bond. The double bond will be 2 carbons away from the carbonyl. So I go to this position. Here the olefin is Z olefin, but we can expect E olefin also. That is this one. Here the double bond is 2 carbon away from the carbonyl group and the double bond is trans. Now let us go to the given options. Here the double bond is 2 carbons away from the ketone. This is possible. What about here? The double bond is 2 carbon away from the ketone and it is trans. So this is possible. The olefin may be cis or trans. So this is the answer.